Lesson 3, and in this lesson we are going to be finding the zeros of the polynomial functions. So you will, towards the end, have to find all the zeros. So the first two examples are the same thing we've been doing. They're asking us to determine if x minus 1 is a factor. Now, realize that x minus 1 is the factor, but the 0 would be what we use to divide by, and you set this equal to 0, and it's x equals 1. Now, to determine if x minus 1 is a factor, we're going to do a synthetic division problem. If we get a remainder of 0, our answer is yes, it is a factor. If we do not get a remainder of 0, then the answer will be no. So if it's yes, it's a 0, no, it's not. So let's try it. So I'm going to put the 1 outside. That's what I'm dividing by. I'm going to take each one of my coefficients, and I'm going to put them in my synthetic division problem. Notice I'm missing an x cubed here. So I need to hold the place with a 0. So in my synthetic division problem, I'm going to put 2, 0, 3, -5, +7. And now I'm going to do the synthetic division problem. So this is the same thing we've done. If I get a remainder of 0, my answer is yes. So let's try it. Bring down. You're going to multiply the outside. So 1 times 2 is 2. Add the column. Multiply again. Add the column. Multiply again. Add the column. Multiply again. Add the column. I did not get a remainder of 0, so I will say no, x minus 1 is not a factor. Let's try another example. The instructions say to determine if it's a factor. Now, in between the two examples, I've added this screenshot from your textbook. Now, if you're ever taking the SAT or the PSAT and they say, use the factor theorem to determine if this factor is truly a factor of the polynomial, what we're trying to look for is to see if we get a remainder of 0 when we do the synthetic division using that factor they give us. So this is the rule behind it. So again, here is my polynomial. I want to test to see if x minus 1 is a factor. Again, I need to find the 0. So I set it equal to 0. So the number I'm using in the problem is 1. So I'll put my coefficients. So I have a 3. I have a -2. Notice again I'm missing a term. I'm missing the x cubed. So I'm going to put a 0 here. Then -8, 5, and 1. Again, I'm going to do the problem, and I need to check to see if I get a remainder of 0. I'll bring down, multiply, add the column, multiply, add the column, multiply, add the column, multiply, add the column, multiply, add the column. Again, I did not get a remainder of 0, so again, this answer is no. Now, I'm going to slightly change the problem. It's not in your notes, but I'm going to take the same polynomial, but now I'm going to add in an x cubed. So let's say I take the exact same one, so 3x to the 4th minus 2x to the 3rd. I'm sorry, I got the wrong exponent. This should be a 5. 3x to the 5th, -2x to the 4th. I'm going to add in an x cubed minus 8x squared plus 5x plus 1. I'm going to use the same factor. Now, watch what happens when I just slightly change the problem. So I'm going to again take my coefficients. So 3, -2, this time it's a 1 instead of a 0, a 5, and then a 1. And again, I'm dividing by 1. So when I bring down, multiply, add, multiply, add, multiply, add, multiply, and add. This time I got a remainder of 0. So by slightly changing the problem, the answer just changed from no to yes. So see how easy it is to make different versions of a test by slightly changing the problem. So just be aware of that. So it's so easy to change algebra test and make it slightly different. So this would be a factor for this polynomial. But when it was missing the x cubed, it was not. Let's try another example. They're changing the instructions slightly. Now they're not saying, is it a factor? Now they're asking you, is this a 0? So they've already solved it for us. Remember when we had to take the factor and turn it to a 0, we had to set it equal to 0. This time what we're doing is making it x minus minus 3, or just flip the sign. So this is now the factor. So just know the difference between what a factor looks like and what a 0 looks like. So here I'm going to do the synthetic division. I'm still doing the same thing, it's just worded differently. So take the -3, put in the coefficients, and again, I'm just looking to see if I get a remainder of 0. So here, oh no, actually it said factor, sorry. So the instructions actually say factor here, but we're still doing the same thing. So I'm going to factor this, or divide it, bring down, multiply, add the column, multiply, then I'm going to add the column, multiply, and I get a remainder of 0. Now, we already knew that this was going to work because they told us from the beginning that this was a 0. What they're asking us to do is factor this thing. So what I'm looking for are the binomials that when I FOIL and distribute will go back to this original problem. Okay, notice the beginning, and the reason why I'm doing a synthetic division problem first is this original given polynomial is not something I can factor easily. Whenever it's a 4-term polynomial like this, the only way I could factor it would be to try to factor by grouping. But that's not working here. So this is why I have to do a synthetic division problem to get it into a more manageable polynomial that can be factored. So I already know one of the factors. It's x plus 3. I'm now going to add the variables back to this. So this becomes x squared, x, this is the constant, this is the remainder. Now I have a quadratic equation that I can factor. So now I need to find the factors of this quadratic, so the two binomials, that when I FOIL it, go back to 6x squared plus x minus 1. And those two binomials are going to be 2x plus 1 and 3x minus 1. I don't care what factoring technique you use, whether you use guess and test, whether you multiply the first and the last term and do it by grouping or do any of the tricks, you just need to find the factors. Now, again, remember, we had one that was given to us, so I need to bring it down. So the original polynomial in factored form,
Can you please send Isabel
Okay, so the factored form is 2x plus 1, 3x minus 1, and then x plus 3. That is the fully factored form of our original 4-term polynomial. Everybody with me on that? Let's try another one. Yes. All right. Next one. Again, they're giving us one of the answers. Again, I'm going to turn it into a factor. So I flip the sign, and the factored form of this 0 is x minus 1. I'm going to do a synthetic division problem to get this polynomial so I can factor it. Again, it's a 4-term polynomial. The only way I could even attempt to factor that would be by grouping, but it doesn't work by grouping. So now I need to use synthetic division. So I'm going to put the 1 outside, write all of the coefficients along the top here, and now I begin my synthetic division process. Bring down the first term, multiply, add, multiply, add the column, multiply, add the column. Again, I already knew I was going to get a remainder of 0 because they told me that this was a 0. The reason why I'm choosing this one is to make my polynomial something I can factor. So this is where I add the variables back in. X squared, x, again, constant remainder. So now I have 2x squared minus x minus 6. I now have a quadratic equation that I can factor. So again, factors of 2, I'm going to use 2x and an x. And then the factors of 6 are either going to be 2 and 3 or 1 and 6. But I need to make a -1 in the middle, so I'm going to use +3, -2. When I FOIL this, it will go back, so let me just show you a quick FOIL. I highly recommend you FOIL. It will double check that you've picked the right factors with the right signs. When I add them, I do get what I was trying to factor. So 2x plus 3 times x minus 2, that will FOIL back. Again, remember you had your original factor that was given, which was the x minus 1. So final factored answer will be f of x equals 2x plus 3 times x minus 2 times x minus 1. That is the factored form. Yes? No, doesn't matter. So the order of those binomials does not matter. Absolutely. Let's try one more. Pretty good on this one? All right, next one. Again, they're giving us one of the zeros. So the factored form is x plus 5. This is a factor. I need to get this polynomial into a form that I can factor. Right now, again, the only way I could even attempt to factor that would be by grouping, but I can't. So I will do a synthetic division problem. -5 outside, all of the coefficients inside here, and begin our process. Bring down the 6, multiply, add the column, multiply again, add the column, multiply again, add the column. Again, you need to make sure you get a 0 here because we already know that this should work because they told us it was the 0. What we're trying to get is the more manageable polynomial that we can factor. So now we have 6x squared minus 13x plus 2. I now need to factor this polynomial. So I can factor it into 6 and 1. And then the factors of 2 are going to be 1 and 2. And they both have to be negative in order to get a positive 2. And again, bring down your factor. So the final factored answer is this. And again, the order of the binomials doesn't matter. You can put the x plus 5 out front or the x minus 2. It doesn't matter. So this is the factored form of the original polynomial. Next one. Anybody still need it? Let's try another one before we move on. Again, this is a 0 or a root or a solution. The factor is x plus 5. I now need to do a synthetic division problem. Write the coefficients. Nothing's missing, so I don't need to fill in any zeros. So then now, I'm going to bring down. I'm going to multiply. I'm going to add the column. I'm going to multiply. I'm going to add the column. I'm going to multiply and add the column. Again, we already knew that x minus 5, or x equals negative 5, was a 0. So if I didn't get this 0 here, I either multiplied or added wrong. So now I'm going to add the variables in. So an x squared and x, this is the constant, that's the remainder. So now again, I have a quadratic equation that I can factor. So again, I'm going to look for the factors of 8. And that's either 8 and 1 or 4 and 2. I'm going to try 4 and 2. And then factors of 3 will be negative 1, positive 3. Again, FOIL that. If it doesn't go back to that, then you've done something wrong. Either it should have been maybe 8 and 1 instead of 4 and 2. You would go back and check it. Again, don't forget to write your original factor they gave you in your final answer. Now, the next part of the lesson, the instructions are going to change. They're going to say, find all of the zeros. So what we do here is we take this one step further, and we take each of the factors, and we're going to set them equal to 0. So I would do 4x minus 1 equals 0, 2x plus 3 equals 0, and x plus 5 equals 0. I need to solve each one for x, so I'll add 1 on this one. So I get x equals 1/4. Over here, move the 3. X equals negative 3 over 2. Move the 5. So I have 3 zeros. And again, these zeros are where my graph touches the x-axis. These are all x-intercepts. If, again, they said to write them as coordinates, again, remember you would write them like this. And the way that you need to double check how many zeros you should have is you could go back to your original problem, look at the original exponent, the largest degree, and this tells me I'm looking for 3 zeros. And notice I found 3 zeros. Now, here's the tricky part. I'm not going to give you a head start and give you one of the zeros. We have to do guess and test and figure out what one of the zeros are to use in our synthetic division problem. Now, if you're using your graphing calculator, you could key the polynomial into your calculator, see where it hits, and then do the synthetic division problem using that number. However, I'm going to show you a technique, and this is the zeros theorem, that will give us possible answers. And I'm going to simplify what this screenshot of the textbook says by showing you in the first example. So, to find our possible x-intercepts, I am going to take the factors of the first term and the factors of the last term. So I'm going to be doing last over first. And the factors of 2, the way I can multiply to get a 2 are either 1 times 2 or negative 1 times negative 2. They will both give me a positive 2. So my possible factors of the last term are negative 1 and positive 1, and negative 2 and positive 2. The factors of 6, the ways that I can multiply to get a 6 are 1 times 6, 2 times 3, negative 1 times negative 6, and negative 2 times negative 3. So again, I'm going to write it in shorthand here and write it as plus and minus 1, plus and minus 2, plus and minus 3, and plus and minus 6. These are the ways that I can multiply to get the 2 and to get the 6. Now, I'm going to take this last over first, and I'm going to turn them into numbers. I need to basically simplify the fraction. These will give me my possible zeros. So what I'm going to do here, I'm going to write possible, and there could be radicals, so we won't get radicals out of these. But these are going to be the possible zeros that I'm going to use in my synthetic division. So the way that I work this is I take the numerator and I put it over each denominator. So for example, I would put 1 over 1, and it's plus and minus. So I would put plus and minus 1 over plus and minus 1. 1 over 1 divides, simplifies to 1. So my first possible zero will be plus and minus 1. Then I take the 1 and I put the 2 under it. So plus and minus 1 over 2. That's the next zero. Then I repeat it and put it over the 3. And then again over the 6th. So from taking the numerator, the 1, and putting it over each one of the denominators, I have plus and minus 1, 1/2, 1/3, and 1/6. I now need to repeat the process with the 2. So I would put the 2 over 1. So this could give me possibly plus and minus 2. 2 over 2, which gives me plus and minus 1. I've already listed it. So let me add the plus and minus 2 here. Then I also do 2 over 3 and 2 over 6. So notice the 2 over 3 I haven't listed, so I put it in my list. But the 2 over 6, that simplifies to 1/3, and I've already listed it. So now I have 12 different options here that I can use for my synthetic division problem. So let's try it. Now, it depends on how good you are at guessing and testing. You may have to do it a couple times before you do a synthetic division problem and get a remainder of 0. I've already done it and gotten rid of the bad ones for you. So I'm going to try, the ones I always try first are either 1 or negative 1. So I'm actually going to try 1. I'm going to do a synthetic division problem, and I'm going to see if 1's a factor or 1's a 0. So I'm going to do 1, and then I'm going to write the coefficients. So I'm putting 6, 7, negative 12, negative 3, positive 2. I'm now going to divide. If I get a remainder of 0, then I'll know x equals 1 is one of my zeros. So bring it down, multiply, add the column, multiply, add the column, multiply, add the column, multiply, add the column. I got a 0 for a remainder, so x equals 1 is my first 0. Now, if you go back to the original, look how many zeros I'm looking for. I'm looking for 4. I've only found 1. So now I got to go back. I'm going to put my variables in to see if I have something I can actually factor. And actually this will become x to the third, x squared, x, constant remainder. So again, I still don't have something that I can factor. So I need to do a synthetic division again, trying another number. So trying one of these. So again, I've already done the work. So the next 0 I'm going to test is negative 2. Again, I'm not going back to my original coefficients. I could, but I'm going to use the ones I just got. So 6, 13, 1, and negative 2. I now need to see if I get a remainder of 0, bring down, multiply, add the column, multiply, add the column, multiply, add the column. I got a remainder of 0, so I found my second 0. X equals negative 2. So I found 2 of them so far. I need 2 more. I'm going to add my variables back in because now it's quadratic. I can factor this. If it's not factorable, then I'm going to do completing the square or quadratic formula. So at this point, as soon as you can turn it into a quadratic equation, because we're looking for zeros, you can choose one of those 3 methods to find them. This is actually factorable. I like to factor because it's fastest, but you could do completing the square and you could also do quadratic formula. This will actually factor into 3x minus 1 and 2x plus 1. Now again, the instructions didn't say factor, they said find the zeros. So this is where I need to set it equal to 0 and figure out what x equals. Add the 1, 3x equals 1, divide by 3, x equals 1/3, subtract the 1 on this one, divide by 2, and x equals negative 1/2. I now have the 4 zeros, so I'll rewrite the original 2 that I found by the synthetic, and now the 2 I just found by factoring that quadratic. There are 4 zeros here. Notice from my possible list, remember back up here where I did that last over first, 1/3 and 1/2 were in the possible list. So if you would have done a synthetic division using any one of these 4, it would have worked. So again, it'll be a trial and error. You may not get as lucky and get them right off the bat. You may have to scrap it and then start again. So you're going to guess and test until you find it. Now, keep in mind that original possible list doesn't include radicals. We can have radicals as our 0, and we can also have imaginary zeros. So the next 2 examples are going to cover those. So let's try the next one. So again, we need to do the last over first to figure out our possible zeros here. So last would be plus and minus 1, plus and minus 5, and then first is just plus and minus 1. So when I put it together, it's just plus and minus 1, plus and minus 5. These are my possible zeros. So now I'm going to pick one, and again, I'm going to pick 1. I like 1, it's easy to do, so I'm going to try my synthetic division problem using 1. Again, I'm going to put my coefficients in. Notice it's missing an x, so I need to put a 0 there. So now I'm going to do my synthetic division problem. Bring down, multiply, add the column, multiply, add the column, multiply, add the column. I got a remainder of 0, so x equals 1 is my first 0. Notice my original problem, it's a 3. I'm looking for 3 zeros. I've only found 1 so far. Got to find 2 more. So let's see if I can factor this thing. Let me add in the x's. So x squared plus 5x plus 5. It's quadratic. I can't factor it, unfortunately. So now, to solve for x in this one, I either need to do quadratic formula or completing the square. I'm going to do this one with completing the square. I'm going to do the next one with quadratic formula, just to show you have options. Okay, you can choose. Okay, completing the square should be fresh in your mind from that quiz. So I'm going to move the constant. I'm going to half my b term and square it. So I get 25 over 4. So x squared plus 5x plus 25 over 4. Add it to both sides. I need to find a common denominator here. So I'm going to change my 5 into negative 20 over 4. When I add them, I get 5 over 4. I need to factor this side. Really don't need to think much about it. If you remember what you got when you divided your b term, I apply the square root method. So it becomes x plus 5 over 2 equals plus or minus 5 over 2, root 5 over 2, because the square root of 4 is 2. Move the 5 over 2. So my other 2 zeros are negative 5 plus or minus root 5 all over 2. So, and my other one was the x equals 1. So here are my 3 zeros. You don't have to. If the radical disappeared, you'd actually have to find the number. Okay, the next one is the same thing, but we're going to get an imaginary 0, and that's fine. So here, again, I need to find my possible zeros. And the way that I find that is last over first. So for this one, factors of 3 are going to be plus and minus 1, plus and minus 3. Factors of 1 are just plus and minus 1. So my possible zeros here are just plus and minus 1, plus and minus 3. So again, when I start my synthetic division, I either need to use 1, negative 1, 3, or negative 3. Again, I'm picking 1. Again, put the coefficients. Again, it's missing an x squared. So put a 0, then the 2, then the negative 3. Let's divide it. Let's see if we get a remainder of 0. Multiply, add the column. Multiply, add the column. Multiply, add the column. So we're going to put in the variables, x squared, x, constant remainder. So x squared plus x plus 3. So far I have x equals 1. That's one of my zeros. I'm looking for 2 more. This time I'll do quadratic formula. Again, it can't be factored, so I either need to do completing the square or quadratic formula on this one. So my a is 1, b is 1, c is 3. So let's try it. So negative b plus or minus b squared minus 4 times a times c, all divided by 2 times a. So negative 1 plus or minus 1 minus 12 over 2, 1 plus or minus negative 11 over 2. Pull out the negative 1 and make it negative 1 plus or minus I square root of 11 over 2. So here's 2 and the other one is here. So I have one real root, or one real 0, and 2 imaginary. So 3 solutions here. So you can get imaginary, you can get radicals, but know that generally the very first polynomial that's given will not be factorable, and we will have to do a synthetic division problem to get it into a factorable form, or at least a quadratic where we can use completing the square or quadratic formula. The homework this is due on Tuesday. It's on pages 329 and 330, 5 through 21 odd, 35 through 41 odd. Any questions?